Hi everyone. Today I'm going to show you a simple IoT based traffic light system created using a Raspberry Pi 5. This project demonstrates how a physical button or a buzzer and LEDs can simulate a pedestrian crossing signal and how the same system can be extended into an IoT device. Welcome to VAS, Walk Across Signals Safely, an innovative IoT based pedestrian safety system designed to make every zebra crossing smarter, safer, and more accessible. In today's fast moving traffic environment, pedestrians often struggle to find safe moments to cross the road. VAS changes all that. Now, what is VAS? VAS is a mobile app based IoT solution that connects with pedestrian crossing equipment installed across an area, such as LEDs, buzzers, and traffic lights. Using the VAS app, a pedestrian standing at any supported zebra crossing can request a safe crossing interval with just a single tap on the mobile. The heart of the system is a Raspberry Pi mounted at each crossing point. It contains two LEDs, green and red, and communicates with a button module or an IoT web server. In a basic setup, pressing the button switches the signal from green to red, allowing pedestrians to cross safely. In the IoT version, this button press can be triggered remotely from the VAS mobile app. The app sends a command over Wi-Fi or the internet. The Raspberry Pi receives the signal and crossing light changes accordingly. When the pedestrian presses the cross now button in the VAS app, the green light for vehicle immediately turns off. The red light turns on. Optionally, a buzzer activates to alert approaching vehicles. A timer begins, giving the pedestrian a safe window to cross. Once the timer finishes, the VAS system automatically restores normally the traffic flow. When the red light turns on for the vehicles, the green light switches off for the pedestrian. When the green light for the vehicle immediately turns off and switches into the red light, the green light turns on for the pedestrian. This is the logic that has to be suitably implemented both on the mobile app and across the internet service. One of the strengths of VAS is scalability, and the system is not limited to a single crossing. It can be across throughout all zebra crossings tied to a centrally VAS cloud dashboard. This allows pedestrians, especially elderly individuals, children, and persons with disabilities, to safely activate crossing signal anywhere within the connected zone with minimum time. It may not take them anymore like 20 minutes or 15 minutes to cross across the streets where there is a zebra crossing, or where there is no zebra crossing, that the implementation of zebra crossing along with VAS is required. Some of the features are one-tap request to cross, real-time confirmation of signal change, location-based detection of nearest zebra crossing, and audio assistance for visually impaired users. You can also integrate with the city traffic infrastructure for automatic nighttime dimming or adaptive traffic flow control. VAS has the potential to significantly reduce pedestrian accidents, and it also empowers pedestrians with direct control and by digitizing traditional zebra crossings. Why this name VAS? It captures the spirit of the project. It is reliable, simple, and smart, safe companion that supports pedestrians and makes city walking safer. It's just more than an IoT project. It's vision for a safer, smarter, and more inclusive urban environment. From a simple Raspberry Pi setup that you will see in the next few minutes to a fully integrated city-scale IoT pedestrian network, VAS brings technology and safety together, one crossing at a time. So let's look at the small IoT project. The components used in this project are a Raspberry Pi 5, a breadboard, which is this, one green LED, one red LED, a few jumper wires, two resistors, which is of 220 ohms, and a 3-pin button module, or you can also use a buzzer instead of a 3-pin button modules. as I have a shortage of jumper wires, I'm just using this button. Now we'll explain you the circuit. The green LED, which is this, is connected through resistor to the physical pin 15 on the Raspberry Pi. The red LED is connected through the resistor to a physical pin 13. The button module has 3 pins, like you see here. 3 pins, which are the VCC. One is the VCC, the ground, which is the negative, and the signal. The VCC is connected to the pin 1. The ground is connected to physical pin 11, and the signal is connected. The ground is connected to physical pin 14, ground of Raspberry, and the signal pin is connected to physical pin 11. And further, the ground from the smaller pin of both the LEDs, the jumper wires are connected from ground of physical pin, which is 6 and 11, 6 or 9, to the physical part of the shorter part of the LEDs, way up at this particular point, both LEDs. So this is the connection. So you can see that. See, both the LEDs, the shorter part is grounded to the physical connection here, which is physical pin 6 and 11, 15. So you find 1, 2, 3, 4, and it goes on. This is the GPIO of the Raspberry, to which the circuit board on the breadboard is connected. Now let's see the Python code in action. The Python code consists of a Flask for website access library, and RPI.GPO library for accessing the general purpose input-output pin of the Raspberry Pi. So the program takes the input for green and red LED and sends the output to the website using the Flask program, and also through using the GPIO. So the functions for the green LED are on and off, and for the red it's also similar. So it defines a function called pedestrian, where it converts the red into green once the pedestrian button is switched on your mobile. If I run the program, the green light blinks, green light is on. That's the start of the program. In case we want to control it from the website, which is more related to IoT traffic lights, you can see the signal. You first first switch off the green and start off pedestrian walking. Suppose I click on the pedestrian walking. Red light which is a normal light when a pedestrian comes to cross the road, is seen like this, and then it switches on to green for the pedestrian to walk across the road. So this is a simple example of how it's implemented on IoT. For convenience sake, I have given these buttons: red off, which brings back it to green, which is of the red light, and red on, which switches on the red light. Both off and red off. We switch off the LEDs. Now, this project can be extended into a full-fledged IoT traffic management system using sensors, cloud connectivity, and automation. The same logic can control real-life traffic light, pedestrian crossings, and emergency signals. You can have a simple app like something like walk across any signal safely, VAS, and then when you switch on your mobile and want to switch on the pedestrian crossing, you can cross any crossing from across the road safely. Especially it can be implemented in zebra crossings. Thank you for watching. This is a simple and fun IoT project that demonstrates how hardware, software, and networks come together. If you like the code or a step-by-step guide, you can feel free to ask.